Arithmetic division is kind of like a shorthand or shortcut method of division. And you are dividing by a linear factor. So you have one of the factors already, and that's what you're going to divide by. And it only works if you are dividing by some linear factor. With long division, it's like what you did back in elementary school. It can be easy, but if you make any mistakes along the way, it's going to mess up everything from there on out. So we got to make sure that we are very careful when performing long division. Whenever you're doing either one, polynomials are basically the same thing. It's just two different ways to do the same process. So make sure that you get the hang of at least one of them. I'm assuming it'll probably be synthetic, would be your decision to on which one you want to do. But make sure you get the hang of at least one of them so that when it comes time for our quiz later this week, you know how to perform at least one method, because I will let you choose your method. Okay? All right, so it says we are going to divide this polynomial x cubed minus 4x squared minus 7x plus 10 by x plus 2. And then we're going to use that answer to factor our polynomial completely. So first it says we are going to do this by using long division. Okay, so remember, long division is when you have this right here. You put the larger piece on the inside, so that would be our polynomial x cubed minus 4x squared minus 7x plus 10. And then on the outside, that's where we put what we're dividing by, which is the x plus 2. Okay, so a refresher here. We aren't worried so much about the plus 2 part when we're deciding what goes into the polynomial. We're looking at the first term, okay? So how many times would x go into x cubed? Or what could I multiply x by to turn it into x cubed or as close as possible? X squared. Okay. So then I multiply this entire factor by x squared. Well, x squared times x would just be x cubed. I also have to multiply that x squared by the plus 2, which would give us, good, so plus 2x squared. All right, and then just like in elementary school, we then are going to subtract, right? Okay, so x cubed minus x cubed gives us 0, right? And then I'm also subtracting this piece, even though the minus is out here, right? It's negative 4x squared minus 2x squared. What's that going to give us?
Negative 6x squared.
Right, so negative 6x squared. Okay, and then just like in your elementary long division, you bring down the next piece of your polynomial, okay? So we're going to bring down everything we got left, which would be our negative 7x plus 10, right? Okay, now I'm trying to think to myself, this x, what could I multiply it by to turn it into negative 6x squared? Okay, so I'm going to put a negative 6x up here. So negative 6x times x, exactly like you guys said, gives us negative 6x squared. I also have to multiply that negative 6x by the 2, which would give us, right. Okay, and now I have to subtract, right? So negative 6x squared minus negative 6x squared. Well, minus a negative really means I'm adding. So really negative 6x squared plus 6x squared, which is just going to give us 0. So those are gone. All right, and then same for the next piece. Negative 7x minus negative 12 is really plus 12x, right? So what's that going to give us? Right. All right, and then I got to bring down what I still have left, which is that plus 10, right?
Thank you. Sorry.
Okay, and then I asked myself the same question. What can I multiply this x by over here to turn it into 5x? 5. So I'm going to put a plus 5 up here, okay? All right, and then 5 times x gives us, right? And 5 times 2 gives us 10. And then we subtract one more time. Well, 5x minus 5x is right, and 10 minus 10 is right. So we don't have anything left. So now what we have is the factor x plus 2. And then this piece up here, our x squared minus 6x plus 5. Well, they said now that we've done this, we should be able to now factor our polynomial completely. So what we ended up getting, this part right here, what would that factor into, guys? What multiplies to give me? So we have our first factor, the x plus 2, and then just like he said, we'll have our two factors of x minus 1 and x minus 5. Okay. All right, now we are going to repeat the same process, but with our synthetic division, okay? All right, so with your synthetic division, you are only going to be using the coefficients, okay? So first, we make a little box here for the piece from our factor. So remember, when you have a factor, if you want to know what it really is, you set it equal to 0 and solve, right? So what is that value from that factor? -2. Okay, so we're going to be dividing it by a -2. When we solve, we get -2. Okay? All right, and then I'm going to go look at the coefficients of the original polynomial. Well, this is an understood coefficient of 1, right? So we'll start there. Followed by a coefficient of -4, and then we have right, and then the last one is right. Okay. Now, if for some reason, guys, your polynomial is not in descending order, you would need to fix that before you do long or synthetic division, right? We need highest exponent to the lowest exponent. So we always do need to make sure it's in order. Okay. So here you drop down your first term. So our first term, we bring down that 1. Okay? Then you multiply this value by the value in your box. So 1 times -2 would be -2. And here you are adding your rows instead of subtracting. So -4 plus -2 would give us -6. Okay? And then you repeat that process. You multiply this number by the value in your box. So what's -6 times -2? 12. And what's -7 plus 12? 5. And then you repeat it again. 5 times -2 would give us -10. And 10 plus -10 is 0. Which is kind of like your remainder, basically. Just like the other one, we didn't have one, right? Okay. These are now the coefficients of your polynomial, and it should always drop a degree from what you started with. So we started with a cube, so now it's going to drop a degree. This should be 1x squared. And this should be -6x. And +5. All right. So that's going to be why it's really important to make sure you have your equation in descending order to begin with, or it's going to mess up your numbers, right? Okay. So, again, we end up with the same value that we got over here, right? Which we already said we know what it factors into. What does that factor into? Right. So we'll have our x plus 2, our x minus 1, and our x minus 5. Again, totally up to you which one you choose to use, but I know most of us kind of like synthetic just because it's a little bit less writing. All right, let's do another one together. All right, so part A, says we're going to use synthetic division and that x minus 1 is our factor. Okay, so if x minus 1 is our factor, what am I going to put in the little box? Positive 1. Remember, we always are taking this, setting it equal to 0, and solving. Okay? And then I'm going to list out my coefficients. What are my coefficients here? Right. Okay. All right, then remember you drop down your first coefficient, and then we multiply, add. So 1 times 1 is 1, and then negative 1 plus 1 is 0. 0 times 1 is, and 4 plus 0 is, 4 times 1 is, and negative 4 plus 4 is 0. And again, remember, this one is always kind of like your remainder, right? Okay, it should always be 1 degree less than what we started with. We started with a cube, so we're going to start with what for these factors? Square. So I'll have 1x squared, right, plus 0x plus 4, right? Do I need to put 0x in the equation? No. So really, this is just x squared plus 4, right? Can I factor x squared plus 4? No. So it said determine if there are any other factors. No, that's where we got to stop, right? So our only factors here are going to be our x minus 1 and our x squared plus 4. Okay. All right, I want you to try B. But just a reminder, guys, that here, whenever you're writing your coefficients, this piece has a power of 4, and it drops all the way to 1. So what do I have to put in those places? Zeros. So make sure you put those in your equation, okay? All right, so give B a try. And then if you get that pretty easily, you can go ahead and move on to example 3 if you'd like.
3, 0, 0.
Oh, I'm sorry.
Miss Rainwater, there was a way to write the remainder, was there not?
Yes, you just write the remainder over your given factor.
The answer's just no.
Yeah.
Four, 26. Wait, no. Yeah. 26.
Sorry.
Yeah, that's about it.
Just like it says here. Right, remainder is a fraction.
So below?
No, at the end.
Oh, okay.
So the factor, the remainder, do we write it like this?
No, it's at the end. Okay, guys. So part B said, is x plus 2 a factor of this polynomial? If not, you need to write your remainder as a fraction. All right, so what did we put in our small box here? -2. All right, and then what were our coefficients? Okay, so -3, 0, 0, 2, and -5. Okay. All right, so what do I do first? Right, bring down my first term, okay? So I bring down my -3. All right, and then what should we do? Multiply. So -3 times -2 gives us 6, and then we add them. Okay, and then what's 6 times -2? And then we add and get -12, right? What's -12 times -2? 24. Which gives us 26. And what's 26 times -2? -52. And what's -5 plus -52? -57. All right. Remember, that piece is my remainder, right? So, what do we think? Is x plus 2 a factor? No, right? Or it would have gone in with a remainder of 0, like the ones we've previously done. Okay, so since it's not, it says that we will write the remainder as a fraction. So everything else stays the same. We started with an exponent of 4. So this term, this -3, is a coefficient for what? -3 x to the third. All right? And then we'll have plus 6x squared minus 12x plus 26. And then it says you write your remainder as a fraction, right? So plus -57, or you could just put minus 57 over what we divided it by, which was our factor x plus 2. And like we said, since it's not a factor, we're not going to be able to factor any further, so that's how we'll leave it. Okay. All right, let's look at example number 3. This one has a few parts to it. It says that they want us to use synthetic division to first verify that the factors that are given are in fact factors. Does it actually work? Okay, then from there, find any remaining factors. So like we did on the front page, factor it further if we can. And then it says we are going to use those results, use all of our factors to write the complete factorization, and then part D is we should be able to graph it using factors, what we've been doing the last few days. Okay, so starting with part A, we're going to use synthetic division to see if these are in fact factors. Okay, so we've got two factors. If I'm going to use synthetic division with either one of those factors, what number am I going to put in the box? 5 and -4. Okay. All right, so let's see here. Let's put -4 in that box. All right, so I'm going to start with the original equation, and I'm going to write down all my coefficients. So what are my coefficients?
1, -4, -15, 58, and -40.
Good. Okay, and now we're going to check and see if it's a factor. If it is a factor, our remainder should be what? 0. Okay, all right. So we bring down the 1. 1 times -4 and we add and we get, right? Negative 8 times negative 4, right? We add and we get 17. Okay, and then 17 times negative 4. Good. So negative 68. All right, and then 58 plus negative 68 would be, right? And then negative 10 times negative 4.
40.
Positive 40. And then what do we get when we add?
0.
All right, so is this a factor? Okay, all right, good deal. Okay, so this was an exponent of 4. I have now gotten 1x cubed, or just x cubed, right? Minus 8x squared plus 17x minus 10, right? Okay, well, negative 4 was a factor. Then if 5 is a factor, then it should be a factor of this piece too, right? We should just be able to factor it further because we don't want to have to start over because eventually we're supposed to find all the factors, right? So we're going to keep going until it doesn't seem to work anymore. So like you guys said, in the box for the next number, we would put a 5. And I'm going to use these coefficients now. So my coefficients are the 1, negative 8, 17, and negative 10. So same process. We bring down that first coefficient and we multiply. And negative 8 plus 5 would be all right, and negative 3 times 5. And 17 plus negative 15. And 2 times 5. Right. Which does, in fact, give us that remainder of 0, right? Okay, so this is 1 degree below what we started with. So now x squared minus 3x plus 2, right? And what will that factor into? Right. Okay, so we have now found all of the factors, right? They have the 2 that we were originally given, the x plus 4 and the x minus 5, as well as x minus 1 and x minus 2. We know we found them all because our original polynomial had a degree of 4, so it should have 4 zeros, right? Okay, so now our last step is just to graph it. So plus 4 tells us we have a 0 at negative 4, right? Minus 5 tells us we have a 0 at, right? And then we're going to also have one at, good. Oh, yes, positive 1, 2. Thank you. I just graphed them at the negatives. Okay. All right. Now, none of these have any exponents to the zeros, right? They're not multiples of each other. So at every single one of these points, we should just cross. My lead coefficient on the original polynomial was positive, right? Because our lead term was x to the 4th. So what are we expecting for end behavior here? And like you guys said, these are just going to be regular crosses. No bounce or wiggles. So it looks something like that. Okay. Example 4 is very similar. So you guys give example 4 a try, and then we'll go over it. Oh, yeah, it doesn't matter which one you use first. Mm-hmm. well, is it in a parenthesis or is it equal to something? So if it's not in a parenthesis, I don't need to change it. It's already solved for. Jackson, try the one on the back.
I did 3. Yeah, but only if it works. Mine did that one. So
Because it works for me, so that means it should work for you.
Wait, but how the freak?
Does the duplicity mean that it bounces?
just figure out what the X is on here. I don't know, it's just, 2 and 2, right? Both are negative, right? 2 and 2 negatives. So now the zeros, you have to graph out the zeros. So